Our next chapter is the principle of mathematical induction. So in this chapter they'll ask you one question. Okay, it is for a 5-mark. Compulsory question it is. So here, what exactly is a principle of mathematical induction? Is nothing but in an algebra there are a certain results or statements, okay, that are formulated in terms of a n, where n is nothing but a positive integer. Now, such results are a formula we are going to prove with the help of a well suitable principle which is based on a suitable technique. So that is called as a principle of mathematical induction. It is very simple. Okay, there is a result, or in algebra there is a formula. For a series there is an inbuilt formula will be there. So such a formula, how you will get it? So we are going to prove such a statement or a result with the help of a principle. Such a principle we'll call it as a principle of mathematical induction. Then how we are going to prove such a statement or a result is nothing but a given statement you need to take it as P of n. Okay, that you need to take it in terms of a n where n is all natural numbers. Okay, hope you guys know the natural numbers. It is from 1 to infinity. It is. There is no any negative values, only a positive. You need to consider the given statement or a result as a P of n. Next, in that, the first statement will be, the first step is, the given statement P of n is a true for n is equal to 1 is nothing but P of 1 is a true. Okay. The second one is, you need to consider if the statement is a true for n is equal to k. You need to replace n by k. Then the given statement is a true. This implies then a given statement will be true even for n is equal to k plus 1. Okay, this is what the light theory, but while doing the problem, you'll come to know what exactly this. Okay, this is important one, and all the problems, it is in the same method it is. You need to consider the given problem or a statement as a P of n. The first step is you need to replace n by 1. There the statement will be a true. Next you need to replace n by k. Then the statement is a true. That means even that statement is a true for n is equal to k plus 1. Once these conditions are satisfied, you can conclude that P of n is a true for all natural numbers n with the help of principle of mathematical induction. Is it clear? So I'll solve only one problem. Okay, you should listen carefully. Is it clear? So I'll just take it one simple result. That is, example, for all n is greater than or equal to 1, prove that 1 divided by 1 into 2 plus 1 divided by 2 into 3 plus 1 divided by 3 into 4 plus etc. The last term is 1 divided by n into n plus 1. This is equal to n divided by n plus 1. So this result we need to prove with the help of principle of mathematical induction. The first step is what? You need to consider the given statement as P of n. Okay, I'll just take it. P of n is nothing but the given. You just write it the given thing. 1 divided by 1 into 2 plus 1 divided by 2 into 3 plus etc. so on. 1 divided by n into n plus 1 can be written as n divided by n plus 1. This is what the given statement. The first thing is what? You need to replace n by 1 and you can say that this is a true for n is equal to 1. While replacing the n value, you need to consider the last term of this LHS. Okay, so now let n is equal to 1. LHS of this statement is 1 divided by n into n plus 1. This one you need to consider, okay? So replace it. 1 divided by 1 into 1 plus 1 is nothing but 1 divided by 1 into 2 is equal to 1 by 2. This is what LHS. Now I will take RHS for the same value. RHS is, that is, after the equal, n divided by n plus 1. I just took n is nothing but 1. 1 divided by 1 plus 1 is nothing but 1 divided by 2. Here for n is equal to 1, LHS and RHS both are equal. If these two are equal, we can say that P of n is a true. Clear? For all the problem you need to do it like this only. Okay? This is what the first step you can consider. Therefore, P of 1 is true. Okay, once you will get LHS and RHS is the same value, you can conclude that P of 1 is a true. After this, let us assume that P of k is a true. You need to consider the given statement is a true for n is equal to k, where k is some positive integer. If the statement is true for k, that means you just replace n by k. Okay? So I just write P of k. 1 divided by 1 into 2 plus 1 divided by 2 into 3 plus etc. so on. This is 1 divided by k into k plus 1. This implies k divided by k plus 1. I'll just call it, this is equation 1. Okay, what you will do, once LHS and RHS are equal, you will conclude that P of 1 is a true. Okay, then you need to assume that P of k is a true. Is nothing but in a given statement, replace n by k. That is, P of k is this. You just call it, that is equation 1. Once you assume that P of k is a true, you need to prove that P of k plus 1 is true. Is it clear? By the definition. Okay. Now, I'll just keep it the equation 1. Now, I just assume this one. We shall prove that P of k plus 1 is a true. Is nothing but, we need to prove that one is a true means, in the place of k, you need to get it k plus 1. Is nothing but, here you should get k plus 1, bracket, k plus 1 will be k plus 2. This is equal to k plus 1 divided by k plus 2 you should get. Once you will get the given statement in that form, you can conclude that P of k plus 1 is a true. Okay, so I can write this series as 1 divided by 1 into 2 plus 1 divided by 2 into 3 plus 1 divided by k into k plus 1. So what I'll do is, once I'll write this statement, after immediately you need to write the given statement in terms of a k. Along with this, you have to write the next term of this. Okay, here is 1 by 1 into 2 plus 1 by 2 into 3 plus 1 divided by 3 into 4. This is what the next term, right? So here what I'll write, the next term will be 1 divided by k will be k plus 1. K plus 1 will be k plus 2. Hope you guys got in this. You just write the given statement in terms of a k. So here after this you need to write the next term of this. Okay. Now I just write this one with the help of a equation 1, I can write. So from year to year, we can write this is equal to k divided by k plus 1. Okay. So for all these terms, I just write only a k divided by k plus 1. Okay. Plus, you just write the next step. That is a k plus 1 into k plus 2. This is using 1. So next you need to go with the LCM. LCM is nothing but I'll just take it here, 2 factors is there. Therefore, I'll take it this as LCM. K plus 1 into k plus 2. So in this denominator k plus 1 is there. These two get cancelled. Remaining is a k plus 2. Here numerator k is there. And in denominator the remaining is k plus 2 plus. We just took this is the LCM. Therefore in numerator we have only a 1. You just write that as it is. Next is multiply k for both the terms. K into k is k square plus 2 times k plus 1 divided by k plus 1 into k plus 2. So I just write this as x square plus 2x plus 1. So that will be a simple form as. You can go with the factorization also, but I'll just reduce the steps. So for that sake, I'll just write it. This is directly as k plus 1 whole square I can write. Okay. Here I'll just expand it. How you will get it? K plus 1 whole square is nothing but a plus b whole square is a square is k square plus b square is 1 square plus 2ab. 2 into a is a k, b is a 1. It's nothing but k square plus 1 plus 2k. Hence we can write k square plus 2k plus 1 as k plus 1 whole square. Okay. And divided by k plus 1 into k plus 2. K plus 1 whole square is nothing but there will be a 2 terms. K plus 1 into k plus 1. So in that one term will get cancelled. Remaining is a 1 more. That is k plus 1 divided by k plus 2. So I'll just rewrite this as k plus 1 divided by this 2 as k plus 1 we can write. 2 as. At the last I can write k plus 1 divided by, I just group it like this. It is a k plus 1 plus 1. In a given statement, if you observe that the RHS is like n divided by n plus 1. So now you need to prove this RHS like k plus 1 divided by wherever the n, there you should get it like k plus 1. So in that case, you can say that P of k plus 1 is also true. Okay. So in the place of n, we got it as a k plus 1. So here also only n is nothing but k plus 1 is there. Therefore, the given statement is the true even for n is equal to k plus 1. So once you will get the statement which is like this, then this problem will end. Okay. Therefore, P of k plus 1, okay, this is not visible. So last you just conclude the problem like, therefore P of k plus 1 is also true. Once this statement is true even for n is equal to k plus 1, you can conclude the problem like, therefore P of n is a true for all natural numbers by principle of mathematical induction. PMI. It is the short form of principle of mathematical induction. This completes the problem. Okay guys, not understood? Yes, this is a light theory. So only the first step if you understood, then for a first step, it is like LHS is equal to RHS, if you do it that one, so from there only you will get 2 marks. Remaining 3 marks, it is for the simplification. Simplification is nothing but how you will prove that P of k plus 1 is also true. Only a thing is how you will write the series. The series is important. You need to write the LHS till the last term. Then you have to write the next term of that. Okay? Don't write it RHS. Then you just make use of the RHS in the next step. And you just go with the LCM and a factorization. Then you just cancel out the common term. There you will get k plus P of k plus 1 is also true. Okay. Once P of k plus 1 is also true, then you can conclude the problem like P of n is true for all the natural numbers. This is by the principle of mathematical induction.